So a first example of being able to use the F-test to determine if there's a significant difference between 3 or more means. Suppose we have 3 brands of cigarettes and they were tested to determine if there was a significant difference in the tar contents given in milligrams. So the following was the results. So they sampled 3 different brands of cigarettes, and here's the number of milligrams of tar in each of those cigarettes. The question is there evidence to suggest that there's a significant difference in the average tar content for each of the 3 brands? We're going to test at the 5% significance level. Null hypothesis. We're going to assume that if the amount of tar in each cigarette is completely random, then it doesn't matter what brand we have. There's going to be no significant average difference. So we're going to say there is no significant difference in the mean tar content of each brand of cigarette. All right. And then the alternative would be that there is. So all we're going to do is we're just going to copy this, and we're just going to say that there is a significant difference in the average of those. Right, so there is a significant difference in the mean tar content of each brand of cigarette. We're going to collect up some variables. So first variable, we're going to collect N1, N2, and N3. Now, N1, N2, and N3 are going to be the sample sizes of each group. So notice that there are 5 elements in the first group. Notice that there are 6 elements, 1, 2, 3, 4, 5, 6, and then finally there are 4 elements in the final group. The overall sample size N is going to be equal to 5 plus 6 plus 4, which is going to be 15. Right. The next thing we need to do is we need to get the totals. So T1, T2, T3, and then from there we're going to get the sum of X. Now T1, I'm just going to write out T1 because it's our first time, and then for the rest of them, then you guys can extrapolate how to get those. So T1 is going to be 14 plus 16 plus 12 plus 18 plus 11. Right? And if we add those up, that should be 71. All right? And I get 30 and 30 from the sum of the first 4 terms, and then 11. So 60 and 11 should be 71. Right? Now we're just going to add up and to get the totals of the other groups. That's going to be 10 plus 11 plus 22 plus 19 plus 9 plus 18. That's 89. And then finally 11 plus 15 plus 19 plus 18. That's 63. Finally, to get sum of X, 71 plus 89 plus 63. I think that's 223, but I'm just going to check really quickly in my calculator, and that is indeed 223. All right. We also need the number of categories. Notice that there are 1, 2, 3 brands of cigarettes. So in this case, our K is going to be equal to 3. Right? And then finally, the last thing that we're going to do is find the F statistic and be able to compute what the test or what the distribution looks like. So F critical is going to be dependent upon 3 things: alpha, and alpha in this case is going to be 5% because it says it right in the problem, just like it's said dozens of times for us. Right? Degrees of freedom in the numerator. All right. Now remember, degrees of freedom in the numerator, we go back up to our formula, and our formula says that degrees of freedom in the numerator are going to be equal to K minus 1. All right. So it's going to be K minus 1, which is 2. So K minus 1, 3 minus 1 is 2. And then finally, degrees of freedom in the denominator is equal to N minus K, or 15 minus 3, which is 12. Now we're going to look in the distribution and we're going to find the F critical value. So we're going to go to, remember, first thing we have to do is we have to go to the page number first. Okay, so first thing we do is we just go to the page with 0.05. So you're going to download the F table, and that's going to be found in Blackboard. You can look under announcements. Right? And you're going to go to 5%. Okay, so you're going to be looking for this, you're going to go to 2 degrees of freedom in the numerator, and you're going to go to 12 degrees of freedom in the denominator. And ultimately, you should wind up with this 3.89. Right? So that should be your test or your critical value for the F distribution. We're going to construct that. Right, here's our distribution. And 3.89 is the cutoff. 0 to infinity is going to be the range. And since we've never seen this one before, that's our fail to reject region is everything to the left. Reject region is everything to the right. All right, so now we have to utilize the formulas, okay? And unfortunately, the formulas are not too nice with this F-test. So I'm going to copy these. I'm going to bring them down so that way we have them. All right, so the first thing we're going to do is we're going to compute this SSB. And notice SSB is equal to T1 square plus T2 square over N2, blah, blah, blah. All right, so I'm going to just hit enter a little bit so that way we have each of these formulas each time. So that's going to be equal to, now remember T1 was 71 square, N1 was 5. Okay, and I'm just getting all these values right from up here. Okay, so we're just going to use the values that we just got. 89 squared over 6, and then 63 square over 4. Right? And then finally we're going to subtract out the sum of x, and if you remember the sum of x was 223 squared and n was 15. All right, now when we do this, we are going to compute this part individually in our calculator. All right, and I'll show you why in a few moments that we're going to do that. Okay, but just for right now, just go with me on this. So we're going to do 71 squared over 5 plus 89 squared over 6 plus 63 squared over 4. That's going to give me 3320.617. So 3320.617. Then what we're going to do is we're going to compute the 223 square divided by 15, and that's going to give us 3315.267. It's a 7 there. And then we just subtract those, and I wound up with that the SSB is going to be equal to negative 5.35. Or positive, excuse me. So that's going to be 5.35. And we're going to hold on to that number. Okay, so let's hold on to that because we're going to need that at the end of the problem. Now this is the most taxing one. All right, so I'm going to go down and just do another page. All right, and what I want you guys to notice is that there's a little bit of repetition in the formula. All right, so right here, this part T1 squared over N1 plus T2 squared over N2, etc., that's the exact same thing as this formula. And remember, we just found that number to be 3320.617. So we're just going to recycle that number, which is why we did those two separately. So this is going to be that 3320.617. Now, unfortunately, this is the difficult part, this sum of x squared. The sum of x squared means that we're going to have to square each of the original values and then add those up. All right, so it's going to take a little bit of doing to do that. But once we're done with that, then the problem's basically over. We only have to do a few more computations. All right, so I'm also going to go back up. I'm going to copy down the original data because I can't memorize it all. And I'll erase it once we're done. So to get sum of x squared, that's going to be 14 squared plus 16 squared plus 12 squared plus 18 squared plus 11 squared plus 10 squared plus 11 squared. And all I'm doing is I'm just squaring each of the different values that are originally given to us. Okay, so plus 22 square, plus 19 square, plus 9 square, plus 18 square, plus 11 square, plus 15 square, plus 19 square, plus 18 square. All right, so we're going to type all of that into our calculator. We're going to get a value for that. All right, so I'm going to delete that because we don't need it anymore. All right, so just bear with me. I'm going to type this in the calculator, and hopefully you'll do this as well just to verify the response. So just be patient with me. Hopefully I didn't make any errors. I got 3545. All right. So our answer is going to be 3545. All right. Now remember, to get SSW, we have to subtract. Okay, so that's just part of SSW. So we're going to take our 3545. And from that, we're going to subtract that 3320.617 that we got earlier. And I end up with 22238. All right. So we're going to hold on to that number as well, because those are going to be the numbers that we go through and we stick into our final three formulas, okay? And this is the rest of this is fairly easy at this point, okay? So next thing we need is we need this SSB. Now SSB is MSB. MSB is equal to SSB over K minus 1. Remember, we found SSB in earlier. We found that to be 5.35, I believe. And K minus 1 is going to be 3 minus 1, which is 2. And I end up with 2.7 or 2.68. Okay. Next thing we're going to do is we're going to take SSW, which is that 222.38. We're going to divide that by n minus k. Remember, n was 15, k was 3. So that's 15 minus 3, which is 12. So 222.38 divided by 12. And that's going to be 18.53. And then finally, we just take mean squares between, which we just computed, mean squares within, which we just computed, and then we divide those two numbers, and that's our F statistic. So 2.68 divided by 18.53. And we're going to get a really small number out of this. We get 0.145 approximately. All right, so all of that work for 0.145 doesn't seem fair. We're going to go back up. We're going to plot that value. Okay, 0.145 clearly falls in the fail to reject region. So this is our F value, our F statistic, which is 0.145. Okay, remember this is our F critical value that we found a long time ago. And finally, what this says is that there's not enough evidence to suggest a significant difference in the average tar content. So we're going to say, since the test value, get rid of the underline, doesn't matter. So since the test value falls in the fail to reject region, there is not evidence to suggest a significant difference in the average tar contents for each cigarette. All right. So a suggestion would be go back, watch the video again, make sure you're okay with the key points and the computations, and then to try the second example on your own just to make sure you're okay with that.